Welcome to Prescriptive Duct Seal Certification Training. This is Module 3, Site-Built Duct Sealing. The topics we're going to be covering in this module include the basics of duct sealing, duct repair and proper support, and of course, sealing ducts. In order to be eligible for this program, at least 30% of the ductwork must be outside conditioned space. Sometimes it's obvious, sometimes it's not so obvious. In this two-story house, we can see that we've got ducts between floors. Those are obviously inside the conditioned space. However, we've got ducts in a crawl space, that's outside the conditioned space, and in the garage, and garages are almost always considered outside. In this case, I would easily argue that over 30% of the ductwork is outside the conditioned space and therefore eligible for duct sealing under this program. When thinking about a duct system in a residential structure, the best way to do it is to think of it in three distinct sections. We have the return section, that's the air being pushed back to the air handler. We have the air handler itself, which has specific specifications surrounding it. Contains the fan, the heat exchanger, or a coil. And we obviously have the supply side. Each one of these sections has special considerations that we'll go into deeper. Here we have a schematic of a typical duct system. As you can see, we have a return highlighted in blue over here. It connects. This is an upflow furnace. And we can also see something called a pan joist. We'll discuss pan joists and the difficulties they can present to the duct sealer later on. We have the air handler itself. Again, that's the fan. The nearer you are the fan, the higher the pressure. The higher the pressure, the bigger the leak. We have the supply side here, and we have lots of good glossary terms here. We have a takeoff. Takeoff is simply a section of ductwork that is intended to take off from the main plenum and go perhaps to a duct run. We have a slip joint. That's just the connection between two pieces of round duct, or it could even be rectangle duct. We have a boot, and that's what the register sits into. And of course, we have elbows. Most of the elbows we see today are flexible elbows. We have risers over here, and again, we have another takeoff. The nearer you are to the fan, the higher the pressure. On the supply side, not only is the pressure higher, but the temperature is higher in winter and cooler in the air conditioning season. It is really important to fix all the holes with great care the closer you are to the fan. It had a silver dollar size hole way out at this boot here and a silver dollar size hole at the plenum. Underneath normal operating conditions, the silver dollar sized hole at the plenum will leak a lot more air than the silver dollar size way out here at the boot. Needless to say, you still have to seal both holes. Typically in residential structures, we have three different types of ductwork. We've got sheet metal, which can be found in a mix and match system, some sheet metal, some flex duct. Homes built, prior to the 70s typically had entire sheet metal systems. We have ductboard. Also, ductboard can be very tricky to seal. The key on understanding ductboard, it's the foil on the outside that is the air barrier. If that foil is ripped up, you no longer have an air barrier. And finally, we have flex duct. And flex duct has some nice characteristics. The interior liner is airtight and it comes pre-insulated. If not installed right, it can be very restrictive to airflow. Pan returns, or cavities used to convey conditioned air, can be quite challenging to the duct sealer. They tend to leak in many places. They can leak where the pan meets the bottom of the joist. They can also leak where the joist meets the floor. In older homes where you have diagonal tongue and groove flooring, that leak can be very substantial. You might want to consider abandoning the return, but make sure you have enough return for the system. Oftentimes establishing a sheet metal or return duct is a good alternative. Also, in cases of, it's just too expensive to fix, the program permits the duct sealer not to seal pan returns. As covered in a previous module, it is important to come up with a plan before you jump into the attic or jump into the crawl space with a bucket of mastic and go to work. You really want to know what you're up against. As most of you probably know, there's lots of disconnects and never connects, and for some reason they're way more common than you might expect. As mentioned in the previous slide, sometimes pan systems don't have end caps. This section over here is fascinating. For some reason, we have a mixing box, we have ductwork going everywhere, and since the beginning of time, this duct was never connected to a register way over here in the house. Here we have a gored elbow or a flexible elbow that got broken somehow, and we have to find a way to reattach that. I would personally just put a whole new elbow in there. But how did we find that? We found it by the ghosting on the fiberglass. Fiberglass is a fantastic air filter. That's why we use it for air filters in our furnaces. Anytime you see ghosting, which is just a collection of dirt, dust, grime on the insulation itself, it's a sign of air leakage underneath and should be investigated further. Takeoffs are simply duct fittings that take off a plenum, a return duct. In any case, they can be leaky, and not only can they be leaky due to poor workmanship, but they also see high pressure in most cases. They are critically important to inspect and seal. Building cavity ducts are used to convey air. However, rather than using flex duct or sheet metal, they use building cavities. Usually these are leaky, they are very hard to seal, and the program at your discretion does not require that you seal building cavities used as ductwork. As this picture clearly shows, duct tape alone cannot fix ductwork. Ductwork has obviously failed, and the duct sections have decoupled from each other. Yes, they didn't put screws in. That was their first mistake. Mastic is intended to stick the sheet metal. Mastic is not intended to stick the duct tape. The duct tape adhesive will come loose eventually. When that comes loose, so will the mastic. The program spec requires you to make a good faith effort to remove all existing tape so that the mastic has good adherence. In cases where you cannot remove the tape for whatever reason, you should make sure that that mastic is extended at least a half an inch beyond the existing tape edge and at least 1/8 inch thick. To summarize what we've covered so far, we have covered the different components of a duct ceiling and what the program tells you to do to adhere to the specifications for those specific parts. Also, we've covered ways to find disconnect, the never connects, damaged, and loose connections. And also, hopefully, we have covered that sometimes it's easier to replace ductwork than it is to fix it. This section will cover duct repair and proper support of ductwork. The topics we will be covering are important, and the reason they're important is if the duct system is not properly supported and it's not in good repair, and if all those joints are not mechanically fastened, it will become leaky once again in short order. This section we're going to cover supporting the ductwork, replacing or repairing the existing ductwork, and like we mentioned before, sometimes it's just easier and more cost effective to replace ductwork than it is to try to fix it. And again, we're going to cover securing duct connections in a way that is long-lasting. Sheet metal ducts need to be supported. If they are not supported, they will flex and put stress on the joints, breaking the mastic eventually. Here we see sort of an old school way of doing it with wire. I like these 2.5 inch pieces of nylon webbing. They are easy to work with, and they give you more contact area and better support of the ductwork. Support it in a way that it is secure throughout the duct system and it doesn't flex when bumped into. Flex ducts needs to be supported at least every 4 feet. And again, especially with flex duct, thin wire really doesn't work. It can actually cut into the material. So use at least 1.5 inch wide straps so you can buy it by the roll. It's quite easy. Limit sagging and unnecessary bends. Matter of fact, if you're going to try to make a 90-degree bend with any flex duct, it's best to use a rigid sheet metal elbow. That will make the system easier to work with and also create less resistance to airflow. Flex duct should not be in direct contact with the ground. This is for obvious reasons. One of is thermal conduction. The other one, if it did not have the visqueen and it was laying on bare earth, you can actually set up an acidic reaction with certain soil types that eats away at the liner. we realize that not every crawl space out there gives you the flexibility of getting the flex duct off the ground. In those cases, use some R4 closed cell phone rigid insulation that you can slide underneath the flex duct and on top of the ground. As we've said earlier, Mastic is not magic. Yes, it can seal a ductwork for life, but boy, unless you've mechanically fastened the system together, no amount of mastic is going to make it permanent. Once again, remove the duct tape or any duct tape around it, connect the two pieces together, try to get at least 3 screws evenly spaced. We realize that sometimes you can't get to the back side of that ductwork, but generally you can get enough screws evenly spaced that you've made a secure connection. Let's talk about connecting flex duct. This program does not allow flex to flex connections. You have to have a sheet metal connector between the two pieces. Just trying to duct tape the two together, well, that's not a permanent solution. What you need is a rigid piece of sheet metal that is the same diameter of the ductwork that acts as a sleeve. As covered in earlier modules, also you have to attach nylon straps on both the inside and the outside liner using a tightener. Let's summarize what we've covered so far. All ducts must be appropriately supported. If they are not properly supported, they can put too much stress on the joints we've just sealed, creating a situation where what we just sealed becomes leaky in a short period of time. If contact with the ground is unavoidable, support the ducts with a minimum of R4 closed cell foam insulation. This adds to the thermal integrity as well as stopping any corrosion of the outside liner or rusting of the sheet metal if it's laying on the dirt. Securing duct connections is a critical part of any duct sealing job. Again, 3 screws evenly spaced. And flex duct sections, if you are connecting 2 sections of flex duct together, you must use a rigid piece of pipe of equal diameter and connect it using tension ties on both the inside and the outside liner. In this section, we're going to cover the actual sealing of ductwork. Sealing of ductwork occurs after we supported them and after we mechanically fastened them. The topics we'll be covering in this section include where to apply mastic. The short answer there is anywhere 2 sections of ductwork come together or any random hole in the duct system. We're also going to cover how to seal those larger gaps that need more than just mastic, and also maybe easier ways to access hard to reach locations. It's really easy to sort of forget that even the small holes can add up to big holes, and one of the tenets of this program is that if you can reach the hole, you have to seal it. And all those small leaks can certainly all add up and make a big leak, and our job is to stop that waste from occurring. Many times existing sheet metal systems are covered with insulation. This is obviously for the thermal integrity of the system. The presence of that insulation alone is not considered a barrier to accessibility. You must carefully remove that insulation to access any joints or leaks underneath it, and then you must carefully reattach that insulation in ways that you find easy to do. Twine is one way. You can stitch it together with 16-penny nails. One thing I'd like to point out about this picture is this ghosting. And again, that ghosting is the fiberglass acting as an air filter, and underneath that we found significant leaks at the joint. One location you do not have to seal, and that is the longitudinal seam on round ductwork. It doesn't fix much by sealing it. It's a very, very small leak you're fixing, and this also saves you from having to strip the insulation off the entire section of ductwork. You just have to remove it from the joints. Finding duct connections on sheet metal systems is not always easy. We have covered ghosting before, and as we can see in this picture right here, there's plenty of ghosting, and that's a good sign. Also, most sheet metal pipes come in 6 to 8 feet length, and once you find one, you can sort of crawl on down to the next section and find the next joint. If the system is not mechanically fastened together, just kind of gently banging on the duct, and where you feel that give, chances are there's a connection underneath it. One thing I would like to emphasize too is that if the duct system is in bad shape, or at least portions of it, if it's rusted out, if it's flaking apart, you might want to consider replacing that section of ductwork. A roll of duct tape is a very useful thing to have in your toolbox or behind the seat in your truck. It can temporarily hold just about anything together. The key word there is temporary. It is not a good way to permanently seal ductwork. According to the specs, you must make a good faith effort to remove all loose tape, and we realize that sometimes you can't. We make provisions for that, but the good faith effort must be made. Before applying mastic, put at least 3 sheet metal screws in. Try to get them evenly spaced as possible, and then you cover with mastic. Again, you want as thick as a nickel. If you have to leave the tape in place, make sure it goes at least ½ inch past the edges of the tape. When applying mastic, it's important to have the right frame of mind. You are not painting. Painting results in too thin of a layer of mastic going in place. You are actually plugging. Yes, you can apply it with a paintbrush, you can apply it with a gloved hand, but think that you're plugging and not painting. The manufacturer specification, it should be really as thick as a nickel. You must cover the entire circumference of the connection. I want to draw your attention down here to a duct system that was allegedly sealed. What you can see here is you can actually read the ink stamp through the mastic. That's just too thin to win. The guy was painting, he was definitely not plugging. Don't be afraid to make that mastic good and thick. The short answer of where to seal is where 2 sections of ductwork come together, or just random dumb holes somewhere in the systems. But obviously, all the takeoffs, the plenums, the slip joints, the branches, the T's, the Y's, the elbows, the flexible part of those elbows, which are called gores, the boots, and the boot to floor connection. Basically, it's where 2 different materials come together in contact. Notch takeoffs. Notch takeoffs can be difficult to seal if they are not properly made. We can see here in this case, the notch takeoff, there was an attempt to seal it, but not a very good attempt. Partially it was because not enough tabs were flattened out and not enough tabs were screwed together. These are difficult to seal. Additionally, in this case, you have to reach behind it to get the back side of it. When you're installing a notch takeoff, get more than 3 screws down there. You'll find that saves you time when it comes time to seal it with mastic. Sealing boxes, often you see these at the top of a drop return. It's important to get the corners and all edges of these systems. Sometimes they can be quite small, other times they're alarmingly large. Sealing pan returns can be difficult and time consuming. What we see here in the lower right hand picture is a material called thermopan. That might be one solution. You drop the existing leaky sheet metal up there, which can be difficult, especially if they're big long nails holding that together. Thermopan is easily stapled and easily sealed with mastic. Once again, I want to emphasize that it is critical to make sure that if you see any panned returns, that there is an end cap in place. When attaching flex duct to sheet metal, it is critical that you use a tension tie tightened with a tensioner on the inside and outside liner. Please note that this program does not require mastic underneath the inner liner and the sheet metal. Occasionally you'll find that rather than crawling in a crawl space, getting on your belly, slithering over hard rocks to get to little tiny holes in certain circumstances, it might be easier to cut one big hole that gives you access to the inside of those leaks from the inside of the duct system. A circle cutter is a nice way to make one big hole so you can access smaller holes. This picture shows a duct sealing technician accessing this furnace to plenum connection here. What you can't see are the smaller holes back here. He was also able to seal from reaching in there. This gentleman also attached a paintbrush to the end of a 3-foot stick, applied a lot of mastic in that paintbrush and smeared a lot of mastic over joints. It formed a very effective seal. What you can't see in the picture is that he actually covered this hole with some duct tape so there are no sharp edges that he was going to put his arm into and potentially get cut on. When he was finished, he boilerplated a piece of sheet metal over the hole. He carefully attached the duct liner also and covered the whole thing after he screwed it on with some nice UL approved metal tape. To summarize what we've covered today, is important, and it's up to you to remove tape, or at least make a good faith effort to remove whatever tape exists on the current duct system, secure the ducts with mechanical fastening systems, and seal the connections with mastic. Once again, if you can reach the connection, you have to seal it. Find all the connections in site-built homes. We've given you a few techniques to do that. Larger gaps may require mesh tape. Repair gaps with sheet metal and mesh tape, but what we mean by mesh tapes is something like a self-adhesive sheetrock tape. If you get bigger gaps, and if you lay that mesh tape down first and apply mastic over the top of it, you'll find you make a cast that is very hard to break. Again, it's up to you to access and seal difficult to reach leaks. We showed you one technique, which is sometimes you get to cut one big hole to access smaller holes. Again, the basic tenet of the program is if you can reach it, you have to seal it, and in order to seal it, you have to mechanically fasten it. Thank you.